Okay, this is part 2 of the 5.1 notes for this unit, and it's going to be talking about asymptotes. So, an asymptote, you may have heard of this before. We see it with exponential equations or functions, so you might have seen that before. An asymptote is a line that a curve approaches as it heads towards infinity or negative infinity. Okay, so you can also think about it as a line that the graph gets really, really close to, but it doesn't touch. There's 3 different kinds of asymptotes. You can have a vertical one, a horizontal one, or an oblique one. Oblique just means it's like sideways. It's like a slant asymptote. We usually denote asymptotes using a dotted line. So like this red line says the asymptote is right where the red line is. And then you can see if the function or the graph is the blue line, then the blue line's getting closer and closer to the red dotted line. So whenever you see a dotted line in a graph, it usually means it's an asymptote. So your function's going to keep getting close to that. And that's how we're going to denote our asymptotes too. So as we learn to identify asymptotes, you're going to sketch these dotted lines on your graph to show that you have asymptotes there. What we're going to talk about today is just identifying asymptotes given a graph. So in these first 3 examples, we're just going to identify asymptotes in each graph and state whether it's horizontal, vertical, or oblique. Remember, oblique is just a slant one. And then we're going to write an equation to represent each asymptote. So let's look at this first graph. So if you see the dotted lines, that's what we're going to kind of look for. I'm going to do them again in red because I think that on my screen and maybe in your paper it's a little bit hard to tell. So I've got kind of like a cross of asymptotes. So the first one let's talk about is I have this horizontal asymptote that sits right on the x-axis. So I'm just going to write HA for horizontal asymptote. And we're going to write the equation for that line. So we're going to think about if I were to write an equation to represent that horizontal line, what would it be? And if you think about that, all along this horizontal asymptote that I'm kind of going over in red right there, the y values are always 0, right? I'm not going up or down on the y-axis. So the equation for that horizontal asymptote is y equals 0. And all horizontal asymptotes are going to have an equation y equals some number. In fact, let's come up to this horizontal asymptote up here and write that. It'd be y equals some number. And a vertical asymptote is kind of opposite of that. The vertical asymptote is always going to be x equals some number. So as you write the equations for these, just know that that's what the equations are going to look like. So I have my horizontal asymptote at y equals 0. Let's actually do the vertical asymptote in green so I can show you the difference on the graph. I have this green, ooh, that was a horrible line. This green vertical line, that's my asymptote, and it happens at x equals -1. So if you see at that vertical line, everywhere along there, x is equal to -1. So we're going to write that as x equals -1. And those are the vertical and horizontal asymptotes. Let's do the same thing with the next couple. So let's start with the horizontal asymptote, this next one. And I see the horizontal asymptote is sitting right here at, why is there a 0 right there? I think this 0 is meant to go right here. So this is actually at -1. That's a very confusing graph. So the horizontal asymptote is at y equals -1. Now let's look at our vertical asymptotes. I actually have 2 in this case. I've got one here at -2, and then I have one here at, it looks like 3. So it's okay to have 2 vertical asymptotes. You just got to write them both down. So I have x equals -2 and x equals 3. Okay. And then in the next graph in C, we also have 2 vertical asymptotes and 1 horizontal. So the horizontal asymptote is going to be at, you look where it crosses the y-axis, it crosses at 2. So the horizontal asymptote is at y equals 2. And then the vertical asymptotes are where it's going to cross where those dotted lines cross the x-axis. So it's going to be at x equals -2 and x equals 2. Okay. So that's where I'm just identifying both horizontal and vertical asymptotes using the equations. Let's do some practice kind of going the opposite direction. So in these next set of examples, I've given you the asymptotes and I want you guys to sketch graphs that have those asymptotes in them. So just know that your graph might look a little bit different than mine, but the important thing is that it has the vertical and horizontal asymptotes that are listed. So I'm going to sketch the dotted lines for the asymptotes in red. So we just zoom in. So in this one I would have a vertical asymptote of 2. So I know that here, where x equals 2, I'm going to have an asymptote. And I have a horizontal asymptote of 0. So then along this axis, I'm going to have a horizontal asymptote. And I'm just going to get out a different color, and I'm just going to sketch a graph. Now, because I've only given you the asymptotes, I haven't given you intercepts or anything like that, it's going to be hard to sketch a super accurate graph. So you're just going to sketch any graph that has these asymptotes that's still a function, which means that it has to pass the vertical line test. So let's talk about what that means. So let's say on this side, my graph looks like that. Notice that my blue graph is getting closer and closer to the horizontal asymptote and to the vertical asymptote. Now what I can't do is draw a graph underneath right here. The reason why is because now, if you remember the vertical line test, it means that I have to be able to take any vertical line and it can only touch the blue function at one point. And in this case, it's touching the function at 2 points at every case. So I can't put that blue graph underneath right there. So I'm just going to put it on the other side, on the right side of the vertical asymptote. It doesn't really matter if I put it on top or the bottom. I guess I'll just put it on top. It's going to look something like that. So notice that you have to have your graph approaching the vertical and horizontal asymptotes on both sides. Okay, let's look at another example. So over here, I'm going to have a vertical asymptote at x equals 3. If you have a different color, pencil or pen, I would recommend using it to draw the asymptotes in, just so you don't get confused. Then I have a horizontal asymptote at y equals 2. So your step 1 is just to draw in all your asymptotes. Then I'm just going to basically draw a piece of the graph in each section. I kind of like to think about this graph as being divided into 3 sections. Here's section 1, here's section 2, and then here's section 3. So you need to draw a piece of the graph in every one of the sections. So in section 1, maybe I'll draw the graph underneath the horizontal asymptote. In section 2, I have a couple different options. One, as you saw in the last example, so I can kind of just put like a U shape right here. There's actually another option for this middle section. I am allowed to cross this horizontal asymptote as long as I only cross it one time. And as long as on the ends, so like on the far left and the far right, I'm still approaching the horizontal asymptote. So it's okay to have this middle section touch the horizontal asymptote right there in the middle. And in the third section, maybe I want to draw the graph up here. I could also draw it underneath the horizontal asymptote if I want. Just think about asymptotes as kind of like dividing lines, right? They kind of divide the graph into different sections and chunks. Okay, let me get my red marker out. Vertical asymptotes, I have one at x equals 5. And x equals 0. This is kind of a cool one because I don't have any horizontal asymptotes, which means that on the edges of my graph, the graph can do anything it wants. Okay, so let's look at just this first, the far left chunk. I know that in the middle, it's got to approach this vertical asymptote. So maybe it's going to do that, and then maybe it's just going to keep going down forever. Okay, that's one option. In the middle section, maybe I want this one to approach the left vertical asymptote, going up, and also going up on this side. And maybe in this third section over here, I want it to approach the vertical asymptote going down, and then maybe I want it to loop back down too. Okay, kind of a funky graph, but this would be a graph that has those 2 vertical asymptotes but no horizontal asymptote. Okay, and remember, when you're just given asymptotes, there's a lot of freedom about how you want to draw the graphs, what you want to do with them, what they want to look like. So let's talk about asymptote notation. So we're going to bring back some of our favorite notation, which is this limit notation, to talk about and describe vertical and horizontal asymptotes. So let's just go through each of these sections one by one. So if you look at, first of all, this graph up here, let's identify our vertical and horizontal asymptotes. I have a horizontal asymptote at y equals 2 and a vertical asymptote at x equals 2. So if you come down and look at this first box right here, I've got the limit as x approaches 2 with this little plus sign right here. So this 2 means that the vertical asymptote is 2, and then this plus sign means that I'm approaching 2 from the positive side or from the right side. So if this is here's my vertical asymptote 2, I want to think about my x values getting closer and closer to 2 from the positive side, or from the side that's bigger than 2. And I want to say, okay, as x is getting closer, so as my x values are getting closer to 2 from the right side, my graph is going up, right? My graph is going to infinity. And that's how I would write that one. If you just move one box to the right, you have the limit as x approaches 2 from the negative side or from the left side. So now I'm saying, let's let x get closer and closer to 2, but from the other side. And on this side, my function is going down. So you would say my function is going to negative infinity. So remember that these infinities, those represent the y values, or what the function is doing. The next little bits of notation should look very familiar. These bottom two boxes are end behavior. The answers to these end behavior are going to look a little bit different than we've seen in the past. I'm actually going to erase what I've drawn up here so that we can just see stuff for end behavior. So the limit as x goes to negative infinity. So as x keeps getting smaller and smaller and smaller as it goes to the left, what is my function value doing? It looks like it's getting closer and closer to 2, right? That horizontal asymptote is happening at 2. And the same thing on the right. As x keeps getting bigger and bigger and bigger, my function values, my y values, are getting close to 2 again, that horizontal asymptote. So here I'm seeing end behavior, where before we would always see end behavior going to positive or negative infinity. When you have a horizontal asymptote, your end behavior is going to be going to a finite number, like 2 or 5. Okay. So I'm actually going to let you guys do the next one on your own. I want you to use this graph. I'm going to go ahead and trace the asymptotes in red because they are kind of hard to tell. So I've got a vertical one right here, another vertical one right here, then a horizontal one right here. So go ahead and use that information about the asymptotes to identify what the end behavior is, and then use the notation to describe the vertical asymptotes and the horizontal asymptotes.